Welcome everyone. We are here to destroy code bases forever for people who are supporting make their job a miserable experience. And we're gonna look at all the ways you can do that. Well, let's hope it's all the ways. There's always more creative ways to destroy something. So, but first, let's make some steps back and see what are we trying to solve in essence, when we are writing software in the first place, because we have code bases that we are destroying. Why do those code bases exist? And what are the steps that make it a destruction rather than building, right? So it's a good question. What are we doing? What is software really? So software originally was created so that it would be easy to change, because hardware, they create the hardware, and once it's in your machine, it's working, it's ticking, it's not gonna change. So they made it abstract enough so that they can run anything. And what they run on it is what we write, right? Like we write a set of instructions, we model problems, we're trying to solve some problems that hopefully actually need a solution. But what we need to consider on top of that is that when you have a software that needs to be developed, then what are the steps of this? First, there's a project. They give you, hey, these are the requirements. This is what we want to see. So a software agency then takes this, you write the code, you start writing it. It takes like 3 months or more, to be honest. That's this. Do you see my cursor? You do see my cursor. Amazing. So on this line, you're developing it. Or if you're on the wrong line, then you end up here. We will talk about that a little. And once the project ships, it's not over. Like if you join, if you start developing, you think, yay, I shipped the project. It's great. We are never going to touch it again. It's going to work forever. But to be honest, that's typically not the case. Sometimes it is, because the project is obsolete, nobody wants it anymore. But if they do want it, then you want to support it. So in that case, you either maintain it by adding new features that they demand of you, or you try to squash the bugs that the QA or the user base has found, because, well, it's shipped. So if there are bugs, it's probably in Crashlytics. So you support it. And this is the part that if it takes long enough that the project didn't become obsolete and people didn't get stuck and need a complete rewrite, then you would be maintaining for legacy software forever. Well, eventually people would say it's legacy, but it works just fine until it doesn't. So first and foremost, the project might terminate. Whatever you're writing for months might never even ship. I have seen this before. Application developed for 6 months and it was terminated. There can be many reasons, like either because they realized that they didn't even need to solve a real problem, they just thought they wanted software, or they ran out of money, so they just shut the whole things down. Incorrect technological decisions is why the one I'm talking of failed to ship, because they had these boxes with like extremely limited memory. Like I'm talking 200 megabytes of RAM, and they were trying to run extremely complex UI and show a video stream. So like they were writing it in with AngularJS on a web browser, right? This UI, and it would have never worked. Okay, like 200 megabytes and the web-based UI, not gonna work. And the interesting thing at the very bottom is incorrect technical design. It's when you have these libraries and tools and frameworks and all that stuff that you pull in, you want to use them, you want to make the best code ever, but for whatever reason, it just doesn't really mesh with the requirements. It does things you don't expect. You get bugs. Nobody can fix them. So all you see is that, hey, this feature, we expect it to take 3 days. It's actually getting 4 or 5. We are trying to fix the bugs. We didn't think these bugs would happen. And eventually, if there was enough damage done, you can actually cause enough damage that you write the software, you're trying to write it. You are like up all night coding the code at like 3 a.m. You don't even get extra money for it. It's just that the deadline is so close. And it still doesn't ship because there's just too many errors. And that comes from incorrect technical design. So what triggers a rewrite? Oh, is this thing showing at the bottom. That shouldn't be showing. Okay, so, but what we are curious about is that it ships. We're supporting it, but eventually the whole thing gets rewritten and the new project is created to solve the exact same problems. So why would this happen? Well, first, maybe it's a whole new platform that we want to support, or we want to rewrite the application from something cross-platform to native. This actually happened in my case in like a year, because they wanted to like have this jQuery mobile thing. They were adamant on creating something cross-platform, and it was terrible. The whole app was like 4 screens, but it still took a month because it was like a feed, and the web did not have something like a recycler view or virtual scrolling and whatnot. This was in 2014. jQuery mobile, yeah, it was like 1.4.5. It was the last version. Like at the time when it was pulled in, it was, oh, it's 1 month old. So it's totally up to date and maintained and all that. Though the whole thing died afterwards, and you don't even know what bugs it had. Like on 4.4.2 Samsung, like the navigation drawer disappeared on a second click and stuff like that. Like amazing things. So instead, they needed it in native, which was done in like half the time with twice the features. Amazing. Or there are cases when it's out of necessity, like Flash, like you cannot run Flash code anymore. It is removed from every browser. Windows Phone, well, it doesn't exist anymore. Swift 1.x, like everyone who wrote their apps in Swift, 4.4.2, well, I said this was 7 years ago. I'm old. I am old. Okay, so Swift 1.0 and stuff, like before Swift 2.0, and honestly, before Swift 3.0, there were two rewrites there because the entire ecosystem was reset, right? Like they changed the language so much, the existing libraries effectively had to be completely rewritten, which means that any app that wrote any code using the language had to be rewritten as well. There's also the case, a simpler case, where it's the, like new visual design, but we also want some new features. And for whatever reason, when this happens, there's often a new development team doing it. And yeah, there can be multiple reasons, like rebranding, but the app is just so tied to like how it looks, how it's structured, that you just have to rewrite it because you need new fragments, new UI, new all that. Well, there's also the option that they ship the project, but there's just so many bugs they just cannot, it just doesn't really work. You navigate forward and back, and suddenly you get null in a toast, and you're like, where did this even come from? Or the most interesting one for us is legacy project is costly to change when new features are added, because the changes take too much time to implement, or adding features causes more unforeseen bugs. This last one is the most interesting. Why does adding a new independent feature have any effect on the pre-existing code base, right? Now that's coupling, and we'll get there, hopefully. So what increases the cost of change? There can be so many ways. Mostly just bad code. We'll see some examples for that. In this particular section, I am going to focus on technologies, which is that outdated, incorrectly used, especially incorrectly used, or unusual tech. And really, it's just the code that nobody wants to touch, because as we know it, if you touch it, you own it, but you don't want to break it because, well, but this code, it's 2,500 lines of JavaScript mutating the same list over and over again. So what do I do with it? And the answer is you sit down and you write it until it gets good. Amazing. Also, I didn't even want to mention that. I mean, that's almost expected. Questions should go in the question section. But okay, so outdated tech. Well, what people don't know, when you're new to software development, you're like, I want to write more code which does something, and then I can share that with the world. People will look at it and be like, yeah, this code is great. It solves problems, or at least it's a really nice sample. It shows that I know clean architecture and data domain presentation, because there was this one article 8 years ago that's deprecated by the author of it. So you show that, yes, I actually wrote this. But 3 years later, you look at it and you're like, wow, this thing doesn't even compile anymore, does it? So eventually, code can become obsolete. When Android support became Android X, Jettifier was a way to somehow keep up so that old projects would still work, but nowadays you would not be able to update. Just the other day, like 3 weeks ago, someone was asking on Reddit, hey, how do I change this Eclipse ADT based project to Android Studio without losing my Git history? It's like, it's 2022. ADT has been deprecated for 7 years. Just how long has this been? How could this even happen? So yeah, either the problem became obsolete, the tool was superseded, or the problem never existed. I think the last one, if it actually no, with libraries that's actually fairly common. You write a library and they're like, hey, I could use this, and when you actually get it, you're like, no, I can't. So yeah, we have a list of outdated technologies, some worse than others, some were really nice. For example, butter knife. Butter knife was a leading tool for like 7 years or so, based on annotation processing for Java, eliminating the need for find view by ID and set on click listener. Back when Java 8 was nowhere, you needed retro lambda to like support lambdas in a click listener. Otherwise, a click listener was 5 lines of code. Like, even though line of code is not really a metric, writing 5 lines and then having to look at, oh, this 4 is just boilerplate, this middle one is the one I care about. Now that's quite a struggle. So thankfully, Jake Warden created the trigger warning with this slide. No. So Butterknife added these annotations like on click and on check change. On check change was really nice, and it worked really well. And it's an interesting thing. I saw a comment from Jake Wharton. I couldn't find it, that's why I didn't include it. But it was mostly that I said, Butter Knife was a wonderful tool. We used it, we loved it. And he said that on his side, on his end, he saw the issues putting in for people and thought that he made a mistake by creating the library. And it's so refreshing to see that this was actually useful. This is the disconnect between someone who's using the library happily and the people who actually encounter problems, and the person who only sees the problems, right? Anyway, back on track. So Mortar and Flow, nobody even talks about them anymore. Scoop, which was basically a mashup from Mortar and Flow, also nobody talks about it. Zherge Anvil, there was a talk about it in DroidCon Berlin, I think 2017 or so. That was pretty much the last time they were like, hey, this project is great, but it needs maintainers. It just disappeared off the grid. Anko, I don't want to talk about Anko. Nucleus, which was an architecture library, but basically it was a way that if OnStart happened afterwards, it would run a network request for you. Mosby, which was doing a lot of things, MVP, MVI stuff, but I don't really know what it did. It was definitely an architecture library. You had to extend the base activity for it, so you know it's good for something. Android annotations, I am going to talk about it. Damn. Agera, Volley, all this stuff. These were all top-notch stuff. People were using Otto to communicate between fragments. We don't talk about Anko. I did not include Anko in any of these slides, thankfully. But Android annotations I did, because I like to look at issues for libraries that should I use this? And then you encounter that, hey, Android Gradle plugin 7.0 just breaks everything because the R constants became like not constants. So they couldn't no longer be used in annotations. So can it support it? We don't know. But what's certain is that it hasn't been touched in a while. It's kind of obsolete now with Kotlin, coroutines, all these new features that make software development less of a struggle. So this comment at the bottom, it says, I think that Android annotations will be deprecated in the future. I was on a project that had Android annotations. The most satisfying thing was removing it. And at the time, it didn't have incremental cap support. So as such, having it in the project made the build times like 6 minutes each time. Incremental build support ceased to exist, okay? Here's another one, most before version 4, which is in 2019, they said, it doesn't support Android X because Android X locked down something internal. Any news? Well, 1 year later, no news. Honestly, this is the last comment, so no news. This is actually interesting because Mosby was very popular. It was an architecture library to like help you have a scaffold for MVP or MVI. but it ceased to exist, right? Like nobody really uses it, not even the maintainers, it seems. That's why it doesn't get updated, right? Here's another one, Nucleus, which says that MVP, MVI, MVV, MVVX does not scale as well as Redux. So I'm stopping Nucleus. Okay, so we check this thing that's recommended, Kotlin, which someone might have picked as a result. And we see that they haven't updated it in 2 years. People literally cannot build their project if it's there because JCenter is down. And honestly, what's even the point of Redux? But oh well. Here's another one. I really love this one. Lyft Scoop. I mean, Lyft is a big company, right? Like they open source their navigation framework based on Mortar and Flow. And they even said that we are going to help you adopt this by showing you a more complex sample that is coming soon. It's deprecated and nothing resembles what they use anymore. So that sometimes you pick a framework of choice, there's no guarantee that it's gonna be updated, even if it's a big firm, or honestly, even if it's Google. This one is a code labs from Agera. Agera was a reactive programming for Android library, it said, where you could define repositories that would like execute a network request every now and then it would like, especially if it's Google. It depends. You really cannot guess ahead of time. But with Agera, people were guessing. They were like, "Well, this is basically RX with specific terminology like unpack and then limit and then transform." And it's like, this looks like something you might use somewhere, but it seems extremely limited. If you wanted to customize it, then well, who knows if it can actually do those things that you need. And once it's done, well, honestly, nobody really used it, so it disappeared in time. So this was in 2016, by the way. So this was before Live Data and View Model came out. So when 2017 comes and Live Data View Model comes out and becomes the actual official support where Live Data is something that's reactive, like why would you even keep this? So even the code labs, I got this picture from Web Archive. It disappeared that much. Okay, so as we said, Google, like it doesn't really matter who created it and at what time, because anything can get deprecated at any time, depending on how stable it is, or rather like how much it is needed by those who are creating it as a solution to a problem, and if this problem actually still exists in the future. So in this particular case, we see that something that was added in March 2020 to Jetpack navigation was deprecated and replaced with a string-based API. So if you were like, hey, I want to use this new Kotlin DSL because it came out as a support for Jetpack navigation, I can finally replace my XMLs, and you followed the guide in 2020, suddenly you find that all of that is irrelevant because it was replaced by strings. Okay, so now we have a few contestants for who's the most incorrectly used technology. I'm going to go with Arax Java on this one, but I really want to give a mention to Event Bus, because Event Bus is considered an anti-pattern, but mostly because it lets you post a message to someone else, anywhere else, you don't know who, from the middle of a function. So if you do that in the middle of a function, you actually no longer know which side is which. I mean, you return a value, but you also posted an event as a side effect. They get that elsewhere. And where is this toast coming from? Like, I have 3 toasts coming. I don't even know where, right? Like, Event Bus can be misused, but it made sense back with Android Priority Job Queue, as long as it was used to communicate results from a background process that process in quotation marks, like a background job. You couldn't really subscribe anywhere, but someone wanted to receive the results at some point. So at that point, you wanted to use an enqueued event bus somewhere in time. There are better ways to do that now, of course, but at the time it made sense. Realm had so much bad rap for like being hard to use because of the thread safety things. Like, it's not thread safe because you need to mutate it only on the thread where the Realm instance was created, because it was based on thread locals, right? Now, Realm sure, you can argue some things about the API design, but this was actually the one thing that made perfect sense. If you have something that is mutable, if it allows access from other threads, then it needs locks. It needs to be synchronized, otherwise the threads won't see the result of the other one. It can result in inconsistencies. So RAM instead said, hey, I'm just not gonna let you do this from any thread. And it makes perfect sense, because if you were on the main thread, you always had up-to-date data eventually. But if you were on a background thread, then why would you want to mutate the UI's view of the data from a background thread? This is a recipe for disaster. Like, the only reason why this works with mutable stateflow is because it has mutexes inside. Data binding, on the other hand, that's also often misused one. People putting all their stuff into one single class called view state, passing that in, and then effectively each property changes, it re-renders the entire binding for whatever reason. So that was an issue, but was even worse. I saw this one case once where someone would put the application state into the views tag and then mutated that tag from a binding adapter. So effectively, it was a way to execute code from XML that was mutating the state of the app. It's like mind-boggling that this actually came up as a thing. But my favorite on this list is RxJava, because when people say, hey, RxJava is dead, don't use it, use suspending functions instead in coroutines. Well, yeah, if your code looked like this, then I actually empathize with you. If I saw this, I would want to remove it. Like, no matter what you use, anything would be better, right? But it's tricky because it's a tool to reduce nesting, right? Like, you are trying to reduce the nesting. And here we have this thing that's like 1, 2, 3, 4, 5, 6, 7, 8, 9 nesting levels in a single RX chain. Like, how does this even happen? We created this tool to eliminate callback hell, and now we have callback hell. How did this happen? And the trick here is that whoever wrote this code, because it wasn't me, this is some code I found in 2016 and kept it for better days. They didn't know about singles, and they didn't know to expose this PR downloader, the download call, as a single. So they couldn't use flatmap single, right? So all they really wanted to do here, instead of whatever this is flatmap iterable on this list, return it with flatmap iterable, and then say flatmap single, and then toList. So that's 3 lines, and it would not be nested. And that's what they originally wanted to do here, but they didn't know that. So what gets the blame? RxJava, because, well, RxJava doesn't know that you're misusing it. Imagine to debug this. Yeah, I'm not sure. I advise rewriting this. Actually, I think that's the topic of this talk, isn't it? So unusual technology, stuff that, hey, it's probably good. People tell you, hey, it's good. Like Anvil, for example, is one. I didn't include that here, but it comes to mind now. Or SQL Delight, also unusual type, but people use it, so we know it's good. In fact, that one is actually guaranteed to be good at this point. But we have something like Conductor. We don't know if it really has any bugs or not. There aren't enough people to use it to test it, but the people who use it typically like it. In most cases, Cicerona is another one. I've read this Reddit post, someone saying that they went to an interview and they asked, hey, do you know Cicerona? And they were like, no. And okay, then bye. And they didn't realize that you can literally just read the code. It's really not that complicated. So it's just a comment queue for actions that are like enqueued while the activity or fragment is stubbed, and it will get processed when it started. Like, it doesn't do much. Oh, well, apparently it's hard to learn, I guess. It actually works well. Honestly, if you look at the source code, it makes sense. There's another navigation framework, Acorn, which nobody talks about, but the author of it says that it works. I don't know. It might. There's also Toothpick, which like is a contestant nobody talks about. Like, you know about Coin, Codain, and Dagger, and back in the day, Juice, which nobody talks about anymore because it's obsolete, because it was runtime reflection based and therefore slow. But you also have Toothpick, which people sometimes use, I guess. There's Badu Ribs. I included it because they are still working on their 1.0 release, which is going to be great when it comes out. Or so they say. I think it's probably going to be. Like, they use it in production. That means they find the bugs. If they find the bugs, then it's probably going to be good. As long as it's maintained, it's all good. If it's no longer maintained, then, well, it depends on how well it supports future changes, right? We'll see. And it depends on how customizable it is. So there's also splitties I hear about, like UI, Kotlin DSL. Who knows? Who knows if this is good? It's probably good. Like, I'm pretty sure the author is doing their best. I know that it doesn't have preview support, so it's a no-go for me, but it could be good. There's also a Voyager for Compose navigation as a replacement for navigation Compose. If you look at the source code, it makes perfect sense. It has savable state holder in it. You know, it supports process that, right? So the most important thing here is that just because it's unusual doesn't mean it's bad. In fact, you can definitely use it as long as it's trustworthy. Ribs used to be from Uber, but Badu made a fork and basically rewrote the whole thing internally to suit their needs with like declarative state management support, because Uber Ribs did not support this. In fact, as they mutate their tree in place, they do not track the tree state anywhere. So that means that after process that they cannot restore it. And that was not good enough for Badu, so they had to revise the entire thing. So this tweet resonated with me, by the way. It says, for me, the semantics of an interface matter, the accompanying documentation, including how to use it, and the suite of tests that show that it works and how you can use it. Code has to work and be usable. So as long as the code works and is usable and doesn't bring in complexity that will eventually make it fail, like tooling complexity, for example, think Kotlin Gradle plugins, third party, then metadata changes and suddenly everything breaks. If you don't have that sort of issue, then yeah, your code, it might even work 6 years from now. I use View Property Object Animator. They only made it Android X supported and otherwise hasn't been changed in 7 years. It works perfectly well. So things to consider when you're adopting a library in your code base. Is it actually useful for you? Like, does it solve any of your problems, or are you just including it because it sounded like a fancy thing? It had some generics in it. Yeah, this will help me make better code, I guess. Maybe, I don't know why, but it looks promising. Yeah, in that case, you probably should ask someone who can tell. That's my advice. It helps to check the source code to see if they are doing anything tricky, like reflective access of things they shouldn't do. There was a library that says, hey, I created this because Dagger is complicated, so here's this thing called shank, and all it did was set a property in a global variable and accessed it from another activity, and then you tell them, hey, this doesn't actually work after process that, and it's fundamentally flawed, and then the library disappeared. So if that's the sort of thing you look at, it looks nice in the README, it does not work. Shank, indeed. Does it have automated tests? It's not necessary, but it's nice. And it's especially better if those tests, if they are there, then if they actually test something, because oftentimes it's like mocks, and nothing. You cannot actually verify if it did anything useful. So you look at the test, it's like, okay, they pass, but what does this mean? So something that's super important to check is number and severity of issues. Any reported open, breaking, bugs, crashes, edge cases. How long has it been open? Are the maintainers responding to it? Do they plan to change it? Of course, that doesn't necessarily mean it will be changed. Like you would see RxJava 3 support in Mosby open since 2020. So yeah, it helps to check if there are issues that are open and if there's any chance that it will be fixed. And it's important to know the tooling complexity of things that make the library work, because who knows if this will actually compile when like there's a new Gradle version, especially that's the thing that can break stuff. So something to consider is that we are talking about all these external dependencies, but they really all just code. So if you write proprietary code at home, yourself, at work, that's code just as much as any open source library you adopt. So all these rules apply. If you include extra complexity that can break in the future, that will make support later harder, right? You might even trigger a rewrite. So it helps, in my experience anyway, to consider, if this was an API written by someone else as a third-party library, would I use it? And that's how we ended up with like a reactive layer on top of SQLite back in 2017. Before Room came out, it was basically what Room is doing, but Room is doing it better because they had better resources, like more resources. And I mean, we were not going to make compile time safe query support, but it was a nice API and it worked. So yeah, try to make your APIs look good. Like if you look at Retrofit, you don't really question it. You see that, hey, I can customize it with a call adapter. I can customize it with these converter factories. They provide those from the outside, but they can be changed. And overall, it doesn't do more and it doesn't do less than it needs to. So that's what good code actually looks like, which is nice because, hey, here's this question, how to write good code? And I think this is a funny comic strip because it says, do things right or do them fast. And if you code fast and it still doesn't work, but it's become a mess of kludges and spaghetti code, throw it all out and start over, rewrite. This is incorrect technical decisions, by the way, that we mentioned earlier. The other one says, do things right or right, code well. Well, even if you're fast, that doesn't necessarily make your code worse, right? Like as long as you follow the principles, it will be good regardless of speed. But are we done yet? Okay, so code becomes bad with, how do they say it? It's the cut of 1,000 thorns, I think. Something like that, which means that the first one doesn't hurt, but it adds a pattern into the code that if it gets duplicated, then it will eventually sink the whole thing. So in this case, code well, are you done yet? No, the requirements has changed, throw it all out. Well, if the requirements change that severely, that means that the problem was obsolete and never actually needed a solution. But the other option here is that there's just so much boilerplate you're writing for no reason that you're just not getting to the end of it. So rules of thumb, minimize dependency, including the inheritance of implementation's details between independent features. Here I'm saying that modules that basically provide core functionality that the entire app relies on, sometimes it makes sense to extract it, but then you need to treat it as a library as if it was just like Retrofit. But if that's not the case, then sometimes it even makes sense to like duplicate some of it because the similarity is merely coincidental. But I included inheritance of because what you really don't want to do is have a base view model that has like two properties in it, like state and event, which is really common. You don't really want this because who said that my view model has to have only one output or has to have one output and it's a channel? Why not two of them? Why not three of them? Who knows? Like you can combine any flows at any time. And you can also combine any mutable, observable mutable property as long as it is in an observable stakeholder, like live data, mutable live data, behavior relay, blah, blah, blah. Did I say live data twice? Behavior relay, mutable state flow, and mutable live data. Either of these work, each of them can be combined. So at that point, why do I restrict that, hey, this thing has a private property or protected property called state that can only have one class in it, and then you need to do magic tricks to support state persistence. So that's something to avoid. Base view models, I haven't. When was the last time I've seen a base view model? I don't think I have in like 4 years or so. Oh wait, never mind. There was one that actually enforced. They were added because the fragment had a base fragment that needed a base view model, and the base fragment also said that, hey, I also have a binding, so each fragment had to use data binding, but you didn't really want to use data binding, but you had to because n-1 had it, and this nth one was like, okay, you are also forced to use it even when you don't need it. And that's something that can break things. If that n thing now needs to be changed, you need to actually remove data binding, for example, suddenly you have quite a bit of a task ahead of yourself. So at micro level, you want to minimize the complexity of each component's inner workings. So mutable variables should be observable, should be combined. Each should be mutated only from one place. And that way you can actually track, like in a debugger, hey, this changed, then only this could have changed it. So therefore you understand what's going on instead of like getting lost in a sea of like intent intent conversions, mappings, and all that stuff. Attempt to keep the number of and name of concepts as close to the original domain requirement as possible. So this, in my case, tends to mean that I typically use use cases, but I never call them use cases. Like I had operations, workflows. I had something like a persist task, which was persisting stuff. These are things that basically were like use cases, but we never call them that because the original requirements never specify them as use cases, right? So you can also add more to this. Like if you have something like reducer, you ask someone, hey, what does it mean to reduce state? And they don't really know. So like if I have something as a top level concept called reducer, then what does this mean for me? You get stuck in it. Or view model delegate from IO scheduler, what does it do? You don't really know. It literally just says, hey, I can inherit these functions into anything from anywhere, which is like, well, I thought that's what DI is for. Try to keep the number of indirections to be as much as is strictly required for correct behavior. So technically, this means that if you are adding more layers just to have more layers, even though those layers don't actually do anything, then you are actually just multiplicating the needed code that you need to like actually get something done. And I added this but at the end because it is okay to use external systems to orchestrate components as long as that external system is trustworthy. So that means that eventually you will find that you need to configure things, and some stuff is a system that you bring in as a framework or library, but it actually just connects your bits and it can work if it's trustworthy. If it's not trustworthy, don't use it. So our goal is to minimize complexity, implement the essential complexity, and minimize accidental complexity. And this is a really scary slide, so I'm going to skip the bottom half. Just don't even look at it. So what creates additional complexity? Cognitive complexity, coupling, and hidden knowledge. So cognitive complexity, you look at the code and you need to think about it. And you need to think about it even though it's a function. Like if it's in a function and it should be self-contained, you're like, okay, I trust this because it works. It's tested, for example, or we just know that it works because it's manually tested. You never know, but you don't need to touch it, right? But there are times when there's all this stuff added to the code that just makes it so much harder to like decipher what the original intent was. And that's the kind of thing that eventually triggers a rewrite. I saw this case where one property was passed through a handler as a message, turned into arg1, arg2 as an object, then casted out. But this was basically an event bus using Android OS looper and handlers. And it's like, you will never decipher that. Like it, I was looking at it for an hour. I got stuck. Like, and technically, that's a blow against event bus, but not really. Also, not against messages. They work. The system uses them, but you never needed them, right? So coupling, it's when you have something, you change it, and it affects something in a way that you didn't expect. And these things should not have been coupled. And the base classes I mentioned earlier, they are very notorious for making things shared between components in such a way. Like back in the day, actually, we will get there. So hidden knowledge is when you need to know about something, but you have no idea ahead of time. So the reason why we're skipping the bottom, because we are going to go through them one by one. So abbreviated, incorrect naming, abbreviated variable names. If you name them A, B, C, X, S, D, T, D, it's not really good. You want to look at them and you want to know what it is. In fact, just today I saw this tweet saying, long names introduce more cognitive mode. It's better to call something P than prod. And I'm like, no, no, it's not. Like nobody's going to know what P means. So another incorrect naming example is when you have scoping functions overused, it renames it to it, and it's the default, so people use it, but you can actually give a name, a real semantic name. So the rule should be that if you cover up the lines, like you look at this line, you want to know what this is. You don't want to read here or here or here to tell what the context is. You just want to give it a name. So in this case, even the Kotlin official tweet says, use it only in the simplest scenarios when its type is clear from the context. So if it's clear from the context, it's on a single line typically, and you definitely want to have an explicit name if you're using map. Here's an interesting and fun example, which English-speaking people, I think they don't run into it as often. So mistranslation of domain concept, there's this site called Translation Party. You write something in, it translates to Japanese and translates back. It was much more funny when translate.google.com was not as good at it. But it changes the terms. So there's this stigma that if you write code, it should be English because English is the language of software. So therefore, it should be English, right? So if you have something like list or set or something, yeah, that definitely should be English. But when you look at it and you have a domain that's strictly Hungarian in our case, because, well, I come from Hungary, right? And the domain is specified in Hungarian. And it's like something special to like accounting, and it has to obey Hungarian laws. And there are no immediate English terms for it. And then people rename stuff to things like account settlement. This is not a word, but it was definitely a word in a code base. Like, what does this even mean? People have no idea. 1 year later, they ask, hey, can you edit this particular section of the code which is responsible for this particular thing? And you're like, I have no idea what it's called in English because we translated it and we don't have a dictionary for it. And it's not really a dictionary, it's like a mistranslation guide. So this is what Google Translate gave us back then. So in this case, I actually recommend that if you don't know the domain of the thing and what it's called in English, just keep it in your language. But if you have something like list or set or other variables that are like strictly code-based, you can definitely have those in English. Like, don't translate those to Hungarian. That does not help anyone. Misuse language features. I love this one. So I read this Reddit comment saying, use DRI, don't repeat yourself principle. If there's a lot of repeated code, like 10 plus lines, copy paste it 3 times. 10 plus is not a lot of code. It's really not. Then the right thing is to generalize and encapsulate common behavior, abstract parameterized clause, delegate, etc. And I countered this entirely, and I'm gonna say Yagni, and this is how you actually introduce coupling between components that should have never been coupled. I've done this before. It ruins code bases for life. So I found this talk by Stefan Tilkov, and it resonated with me when he says this. In the talk, why software architects fail. So the talk says, I can actually solve this problem once with a generic solution. My life is going to be so much better because you can like reuse this behavior everywhere, even when it's no longer needed, right? That's when you turn into the enthusiastic architect. This is a really critical phase of your life as a developer, as this is when you can do the worst things to other people and systems around you and really ruins people's lives and make them miserable. That's what he said, and it's accurate. I see that the time I have is steadily decreasing, so I'm going to speed up. So overusage of interfaces. In the solid principle, there's this I, and people tend to say interface segregation. I just need an interface for everything. No, if you add an interface for everything, then it will just keep the exact same dependency chain, but it's not going to change anything, except you now have double the code. So what you want to do is check. If the interface has only one correct implementation, there's literally no reason to create an interface for it. If you want to mock it, we'll see that on the next slide. So the purpose of an interface is to be able to split off the dependency graph so that you don't have a component that's like 10,000 lines long, because at some point you want to cut it off and have a different behavior there. So in this case, we would have view model, and we want to swap out the use case for whatever reason. Let's go with that. Let's say that we have these two components. We could potentially add a new interface called action handler. It's defined by the view model, and the use cases could potentially implement this, and that way we could supply these use cases as a separate thing. But the use cases depending on this view model interface, it's a bit shady. In solid, there's this dependency inversion principle, which this would violate. So in this case, what you could do instead, which is, I think, very interesting, is that you have some external component that knows about the relation of these two things and knows which implementation to provide, but the view model only sees the action handler, and the use cases don't depend on the view model. So someone connects them, and this is what DEI does. This is dependency injection. Someone else on the outside making this configuration, because it needs to be split off. The components are separate, but they need to know about each other somehow. And someone is responsible for doing this, and it cannot be either of them. So it has to be a third component, and that is the I. So yeah, components. Kent Beck, the creator of TDD, says, do you mock absolutely everything? My personal practice is I mock absolutely nothing. If I cannot figure out how to test efficiently with the real stuff, I find another way of creating a repeatable feedback loop. I just don't go very far down the mock path. If you have mocks returning mocks, your test is completely coupled to the exact implementation 3 streets away, not the interface. Of course, you cannot change anything without breaking the test. And that's why TDD had a bad rep. But in reality, it was because mocks were misused. You want to test using the public API, and you don't really want to know what the other things are doing. You want to make assertions for what they tell you, but you don't want to know how they work. So back on track, misused inheritance, inheriting behavior. Well, watch these 2 talks at the bottom. They are really useful. I made terrible mistakes with this. Missing use of inheritance, instance of chains. You can end up with these blocks that this, again and again. And without sealed classes, you would have to remember all of them that, hey, I added this new subtype. There was a pattern called the visitor pattern to fix this, but now you can just use sealed classes. Something to keep in mind is that highly nested conditionals can make your code hard to follow. For example, in this case, you could have like 4 nesting levels, or you could just have these guards. And the right one is much easier to read top down. You know exactly what's going on at the very bottom, which is the thing you actually care about. Not enough functions. Do I need to say more? This onCreateView function is 400 lines long. I'm pretty sure you can do better. But there's another problem, which is if you have too many functions. If you have too many functions, then you need to consider that each function you bring out is a theme. You can call it from multiple places now. It has a name. It seems important. So if something, some logic can only be called from one place and should only be called once, but now I actually expose it to be used from multiple places. So one possible solution is local functions. In this particular case, I show this setup views inside onViewCreated. Like it's literally called onViewCreated to set up for your views. There's no need for a second function. And init observations, if I call this twice, I call this in like onStart, then this thing will observe multiple times. And it would be a misuse of live data, right? So this is the most interesting thing, because just earlier we were chatting about how this looks completely normal, because this is what Android developers do. They have a fragment, a view model delegate sometimes, I guess, use case, talking to repository, talking to a data source, talking to key value storage, which talks to an actual shared preferences helper. But all I wanted was to call edit, put Boolean, apply. And to make this happen, because of this architecture that we added ahead of time, who knows why? I guess we read it in an article. Hey, it's clean architecture. There's never a second implementation of this. We just wanted this one line. And I added 3 modules for Dagger. I added 1, 2, 3, 4, 5. Actually, it's 5. You mutate 5 modules to add 4 classes, which then just call this one thing called shared preferences helper, which is already a terrible name. Like you have something like key value storage. That's something that you can trust. So in reality, this is all I wanted. I just wanted to see the key value storage from the view model. Everything else on top of that was just an unnecessary delegation chain. And adding those 13 classes for no reason, that's how you turn a task that takes 5 seconds, 10 seconds into an hour. And that's what actually contributes the most, in my experience, to things taking long, apart from the coupling. So something that is very well known as an issue, exposing mutable data structures from public functions. Like you expose something like array list, you can mutate it from outside, and the internals will say, oh no, this changed. This is not what I knew about. And so I need to tell you this story about parsable classes that had war and array list in them. You change them on one screen, you pass it as a fragment argument, you change it on the other screen, and it changes on the previous screen, but only if process that didn't happen. And you're like, hey, why did this change on this other screen? I didn't pass anything back. Yeah, but you passed it forward and you mutated it in place. So like, don't use mutable variables in parsable classes at all. What I do recommend using is unmodifiable list. It's wonderful, and use vals. Something that can also help a lot is not using this data domain presentation setup. It's well known that as a top level layering, it does not scale at all. Everything gets mushed together in the domain or the presentation, or both, to be honest. And activities, adapters, fragments, this packaging style, I see it so much, and it's so not good long term, because now every activity is next to each other, but the only thing that they have in common is that it shows the screen, you can launch it. But other than that, they have nothing to do with the feature they represent. Be very skeptical of domain modules. And definitely don't structure UI layer packages by type. There's this link. It's also at the end. It helps a lot. Interdependency between unrelated features. Well, if you have Dagger configuration, it should definitely not be like this, like use case module, repository module, and each time you add a new feature, you mutate all 5 of them. This is what I showed earlier. In fact, the mapper module is like completely obsolete. You can use an extension function. You're not going to have a second implementation of a mapper. I guarantee this. Consider the bounded context of a given context, whether they can be tangled together. In this case, there's no context here, it's just types. It's completely random. Sometimes the symmetry in implementation is merely coincidental. Be very skeptical of domain. And some other concepts to consider, cyclomatic complexity. Like if you have more and more and more Booleans in the same function, then that increases the cyclomatic complexity. And it's interesting, I have seen this done in an MVI code base. It said suppress warning by sonar. This is totally normal that it's 20 cases in this single function. It's one function that does 20. People were asking, hey, if I pass a Boolean, this function now does 2 things. But if you pass in a CL class with 20 subtypes, suddenly it's an architecture. Temporal coupling. Dependence on that. If one function is called, the other must also be called afterwards. Yeah, you can reduce that with the observer pattern. That's why reactive state design helps a lot. I had a talk about it last time. I recommend watching it because I'm not going to go into detail here. Be very vigilant with global variables, especially if it's like passing a result from one place to another. It's like basically a flag. And you read it from the other place, but does the other place exist? Does it even know that it needs to be read? Like if it's observable, it can be okay, but then you need to know that the process that happens, then it like gets cleared. So there's all these things to consider. Minimize the number of places where one mutable property can be changed from, which is pretty much the opposite of what MVI is doing. You have these 20 things, and each reducer changes this. In fact, even if you have something like show loading, hide loading, you mutate the same property twice, even though you're just observing one property, which is, I'm loading data. That's all I need to care about. I don't need these functions that I can call from places, and now it can be out of sync. And consider if state is changed in place, those changes should be observed if anyone depends on it. This is why live data and behavior relay and mutable state flow are so helpful. So conclusion, decisions during the creation and or usage of code is a continuous process of cost-benefit analysis. Does this actually help me if I use this code? Does it solve the problem? Could it be simpler to use? Could it be simpler internally as in terms of internal behaviors? Will others understand what I wrote here? Like, what is the onboarding of this thing I'm using? Is it complicated? Like, is there documentation? Will they ever be able to figure it out? We'll discuss problems down the line. If there's like a new Gradle plugin, build tool is coming out, will it break over time? Can I still compile this project in 2 years? Even so, by following some guidelines, we can minimize edge cases, reduce coupling, and allow for more seams for potential change. That's why you don't need to throw it out just because you're coding well. You reduce the complexity to the bare minimum, but it doesn't mean that you throw everything into an activity. A view model makes sense. Many of these things make sense, but not the chains, especially if the chains don't do anything. In the end, rewrites are actually normal. I have seen multiple rewrites. It seems to happen like every 4 or 5 years at most. Well, I've seen one that was like 10, but still. rewrites do eventually happen. It might be by someone else. It's gonna be their work, and eventually they will create something good, hopefully, or it will get rewritten as is done with software. So there are links. I recommend these talks, especially the last one and the first one. Here's one. Here's some resource about using Dagger Android. Mostly I added it because of the use case module. Like, don't do this. I have a sample here for simpler cases. There's one on Codebases, which didn't make it into the slides, but it's very interesting to read. And there's this one about package structure. Q&A, do we have time, or am I overlapping with the next speaker?
Well, if I can pause for a second, for the sake of all you listeners in my position, where that was a very difficult bunch of information to consume, if anybody wants to have a drink, it's a good time. He's finished.
Oh man, I wish I had. I only have water. I actually don't have water. Oh no, I'm out. Oh well. I will reward myself later.
It's okay, guys. It's gonna get better. I promise. Okay, Gabor, thank you so much. Let's do a quick run through. Let's say whatever you can capture in about 5 minutes at 08 your time. Because
okay,
I don't want to start Sierra's talk more than 10 minutes late. She's been generous enough to allow that the additional 10-minute allotment towards you. So
sorry.
All right, we'll just give everybody about 30 seconds to vote and post your questions.
Hope you enjoyed the talk, though.
Gabor, I know you well enough at this point that it was my fault for not thinking that if you said you were giving a half an hour talk, I should have just assumed it would be minimum 2 hours.
The issue here is that with code, the estimates work, but with the amount of time I can spend talking about things, apparently that's off.
And you were speed talking.
Yeah, I actually rushed through the end.
All right, start it off. Somehow my question got voted up.
How do I teach my phone to apply process that when I shout your name at it? Well, to be honest, you need to ask someone who uses Tasker, because if you use the app called Fill RAM Memory, I'm sure you can run it. Select the button that starts the filling RAM process, and eventually everything will just die on your phone. It's great. But I don't use Tasker, so I don't know. Is MVI the best architecture ever made? It seems to be popular lately, and I'm particularly concerned about what is popular. Thanks, Ryan. Okay, so MVI, it's funny because you have this concept called functions. You can call them in a typed language, and you have this thing called types, which lets you see these functions. Like I press Control Space and I see them. But because MVI is based on Redux, and Redux comes from the JavaScript world, they needed one callback because you didn't know that the second one was added. You don't see it. So as such, when you are like sealed class and actions of whatever, if you don't need a strict serialization of those UI events, and you don't need to support undoing them, which is what you would need this queue for, then you don't need MVI. Like it's a command processor pattern. That's what it's implementing internally. And using one function to change everything, which is, well, questionable. But
you've got 2 minutes.
Okay, let's go forward then, because MVI, use MVVM. It's much better for you.
Sorry, I don't
just combine stuff. What's your opinion about creating abstractions and interfaces to force developers to create things? Oh God, in the same way, for example, the famous base use case or base view model or base fragment, or I don't know what else. So all use cases have an executor invocation. I know you don't like that. Just don't do it. That's the exact opposite of what I was advocating for in this talk. And I have seen it done. I have done it. Don't do it. It's bad for your code base. It's literally what will kill the whole thing the moment you need some fourth subtype of base flow use case. No, what was it again? Like, especially operator for the invoke, it makes code less harder to navigate. Like if you use Alt F7, it won't tell you where you're using it. Just stop using operator fun invoke for use cases. Just call it execute. And definitely don't have a base class for it. There's literally nothing you're sharing. Nothing. There's no similarity between them. And even if there was, they are used for different features, so any sharing between them is a liability. Yeah.
Okay, there are more interesting questions, but we're out of time.
So
If Gabor, it's
Mhm.
I don't know, like 11 or 12 for you right now.
It's 1 a.m.
It's 1 a.m. Oh yeah, you're the only speaker I really don't care about what time I. So if you're still gonna be around, maybe after Sierra's talk, to answer the remaining questions.
I want
Then
one question to be answered by Lokik Sony, which is where to put broadcast receiver for battery details and clean architecture, data domain presentation. One, this data domain presentation thing is completely bonkers. Don't do it. Even the people who created it said it's a bad idea because they used it and realized it's bad. And once you get that done, you realize that the broadcast receiver is a system level component, so it goes next to your main activity or your application class.
okay, sweet. And I'm just putting Madonna's question just because she asked one that's already been answered. MVI or MVVM? You answered MVVM.
Well, yeah, I would say MVVM, use combiners. People gave it a bad rep, MVVM, because they didn't know how to combine things. Use combine tuple. I have a talk about it. It's the previous Android Worldwide talk. It helps so much.
Okay. All right. Sweet. So we're going to switch over to Sierra. I'm going to end this session. Gabor, thank you so much. You have been amazing, not only in terms of content, but just sheer entertainment.
I'm glad I helped.
All right. Bye, guys.